Demands placed on hardware by multimedia systems, storage, processing, and displaying. So we need to understand that because of multimedia systems and the fact they use all these different media types in image and video and animation and audio, they've all got relatively large file sizes. And so we're going to firstly take a look at, before we look at the hardware, the actual things about these media types that place demands on the hardware of a system. So firstly is the increased resolutions and bit depths for the representation of color and image data in animation, video, and image. So the more pixels you have on screen, the more colors available to those pixels. That'll increase the file size of our media file. Secondly, increase sample rates and sample sizes used for producing good quality audio. So the amount of times a sample is taken from a sound wave in order to create and digitize audio. That increases file size, and the amount of sounds available for each sample has an increase on file size. The increased amount of frame rates in the fluid production of animation and video data. So the amount of frames you have per second, and when you do your gaming, you really want that 60 frames per second. That's pretty much standard now. We go even higher now these days that big publishers are going for. That's going to increase your file size because there's more images per second, greatly reducing the size of the video file. And finally, the large file sizes of media when uncompressed. Okay, while we're developing multimedia, we can't compress it because we still need to edit all the details about what we're creating. So uncompressed formats, okay, used for creating our different media types, our video, our audio, and animation data, means those files are large while they're in production, and then obviously when they're finished, then we can compress them and bring that file size down. So these are the areas of demands that put impact on the actual hardware of our system. So the more colors available, frames inserted, or samples taken from audio for a multimedia product, it will result essentially in an increase in the quality of the multimedia product, which is a good thing. But in turn, it will increase the file size of the multimedia file exponentially for those reasons I've just mentioned. Okay, so we need to obviously find some way of balancing this out. Okay, and obviously after we create it, we do compress, and that brings the file size down. But still, they're relatively large files. But if we're talking about wanting to view things in high quality or talking about multimedia production, we do need to focus on a few areas of hardware in order to ensure we satisfy these demands. So the first area is in storage and retrieval. And what we're talking about here is primary storage relating to random access memory, and secondary storage, our hard disk drives, solid state drives, and optical disk drives. So a system's primary and secondary storage will be impacted as a result of storage of large file sizes of multimedia, while both uncompressed and in production, and then as well as once published. In relation to primary storage, with RAM, it's responsible for the presentation of live data. That data is on screen. So while you're editing a video in a video processing software, or you're developing audio using something like GarageBand, while that's in production and you're working on it, RAM is working. It's producing the actual data on screen. So it puts RAM under a lot of stress. And obviously, RAM being the primary memory source of the computer is working in conjunction with the CPU. But we'll get into that more next when we talk about that later. The secondary storage devices, such as the hard disk drives, solid state drives, and optical disk, are all required to physically store the multimedia data on a system for usage. Okay, as we previously stated, while uncompressed during the production of these files, they consume a lot of memory and drive space. Therefore, large amounts of primary and secondary storage are required in multimedia production. Okay, but then also once it's published, we then send it out and distribute it. Now, these days we do use a lot of streaming and online stores, but traditionally the actual medium used for doing that is optical discs for distribution. And so these discs obviously need to have a large amount of space, and hence that's why we've seen the rise of Blu-ray technology, okay, to allow these to be larger games to be distributed, okay, with up to 50 gigabytes of storage on that disc. But even these days that's not enough because you install the disc and then suddenly you need to do a day one download to download more stuff from a server so you can get the full game onto your system. So that's in relation to storage and retrieval, our RAM, our hard drives, our solid state drives, and optical disk drives. The next area is in processing. So we're talking about here the main processing part of the system, which is our CPU, our central processing unit, which does all the processing. But once again, highlighting RAM, RAM being the memory location where data is stored through the fetch execute cycle in order for the CPU to actually have data waiting and then be processed once it's been allocated that time. So demands placed on processing come as a result of data frame rates, image processing through morphing and distorting, and animation processing, which includes tweening. The processing and impact on both the central process unit and random access memory in order to efficiently produce the multimedia and data effectively. Okay, that's where all the pressure falls upon. Okay, CPU has to process all this data, convert all the calculations of all those aforementioned things in related to frame rates and image processing. So we need to have a good high powered processor, a multi-core processor in order to do this, especially in multimedia where there might be multiple videos and images and audio coming in the background happening at once. Okay, the system needs to be able to process all that data at once. Okay, the CPU is responsible for physically processing data, while RAM is primarily the memory location where data is stored when being sent for processing. The efficiency at which these two components can complete these operations will impact on how the multimedia is ultimately going to be displayed. Okay, if you can process all this data efficiently, we're going to see nice, fluid multimedia being displayed at a high resolution with no problems. But we obviously need to have a high powered CPU and a large capacity RAM in order to do that. If we don't have those things, we're going to see a lot of jitteriness in our video and animation frame rates, okay, and perhaps distortion in our audio, okay. It will affect how the multimedia is ultimately going to be displayed at the display end because the system can't process it at a high enough quality. So CPU and RAM are ultimately responsible through the fetch execute style, okay, for the processing. Finally, we're going to talk about displaying, and I've already touched upon this, how the processing will ultimately affect the display, but also we're talking about a display devices on their end. So for image display, we're talking about our monitors and our high definition or 4K monitors. Okay, I've said high definition here because I'm showing its pixels there. Okay, and then obviously for sound, we're talking about speakers. Display devices are impacted by multimedia applications as a result of pixels and resolution. Increased resolutions and greater depths for the representation of colored data in image, animation, and video media impact on the display of media on screen by a monitor. Okay, so if we're going to produce a high resolution image for whether it's an image or a video file, well, we need the matching monitor. If I made a 4K video and I'm watching it on a HD screen, well, I'm not seeing 4K quality. I need to have a 4K monitor which has 4K pixels to view that 4K media. And once again, that needs to be processed by my CPU and RAM that we talked about for processing. So they affect each other. The display of these media types is supported by a system's graphics or video card. So that helps process these parts of the actual image and resolution, okay, to be displayed on my monitor. Speakers are in a similar fashion in that they're required for the display of audio data, which is needed to produce sound stored in a variety of sample rates and sample sizes. Okay, so high quality audio needs to be produced by a speaker. Similarly, with speakers, they you need a sound card to assist on a system in order to convert that digital sound into real world sound. So with displaying, for displaying images and video and animation, we're talking about the monitor, and display of sounds, we're talking about speakers at a basic level. Obviously, we can use projectors as well for displaying video, as we've talked about in other areas of this unit. And for speakers, we can talk about full sound systems and stereo formats and things like that too. So I hope this video has given you an understanding of the demands placed on hardware by multimedia systems, essentially under the three categories of storage and retrieval, processing, and display, and how they overlap with one another. And essentially, we need high-powered systems with good RAM, good CPUs, a lot of secondary storage space, whether it be a hard disk drive and solid-state drives, and good display for the creation and editing of our media in the forms of monitors and speakers so that we can see our development of high quality multimedia. So I hope this has shown you that connection and the importance of the hardware on our systems in creating good quality multimedia.